Assalamu alaikum everyone. Today we are going to conduct 28th lecture of this online course, microprocessors and assembly language. And today's topic is control flow instruction. So let's proceed to our topic. Okay, control flow instruction. These are very important instruction from the perspective of flow of program, how you are going to execute instruction by instruction each program, and if there is any break, how these control flow instruction plays important in these break, plays important role in these breaks. So we know that 8086 or 8088 microprocessor executes each instruction one by one, and this is not only true for 86 or 88, this is also true for any other type of microprocessor, but right now we are just focusing on 86 or 88 in this course. So we know that microprocessor executes each instruction one by one in a sequential flow. That means if instruction 1 is executed, so next instruction which will be fetched inside the microprocessor is basically second instruction, and once that second instruction is going to execute, then the third instruction will be fetched, and this process continues onwards. So we know that, but control instructions are instructions which can alter these flow, or which can alter these equation execution path. For example, we can simply direct after the execution of let's say we were executing instruction 1 and instruction 2 was on fetched. When execution of 2 was in process, then execution on fetching of third instruction was in process. And similarly, when that particular instruction was being executed, we come to know that okay, since probably that third instruction was control flow instruction, and that can directly lead towards what instruction number 100. So that is the magic of control flow instruction. So it can break the sequential flow of execution path. These instructions are very important from the point of view of control flow, and user can easily control them. That is the magic of this instruction. So let's see how we gonna use them. uh, okay uh, okay so a very important point, it can control flow instruction can easily skip one or a group of instructions. So you can actually skip only few selected instructions or few groups of instructions, or you can skip just one instruction as per the need of your application program. Furthermore, it can cause actually execution of certain instruction to be repeated. For example, we know that we are going in this flow. Let's say, let me draw instruction 1, then instruction 2, then instruction 3, then instruction 4, right? And somehow there was a break, it leads towards back to instruction 2. So program will repeat instruction 2, instruction 3, instruction 4, and again it will repeat. So this is called looping also, and you have seen, I hope you have already seen these kinds of examples when you were discussing loops or addressing other kinds of loops. So this is also the magic of control flow, that you can actually create different size of loops, and you can actually define number of times they can be repeated. So all these can be performed using this control flow instruction. So this is also part of control flow instruction. Okay, in this slide we are going to discuss about jump instruction, where that is JMP is its mnemonic, but jump instruction is the name of instruction, and it is always considered a very integral instruction whenever one is going to talk about control flow instructions. So jump instruction is very important instruction, and let's see what we are going to learn about jump instruction. So jump instruction is dedicated for control flow instruction in 8086 or 8088 microprocessor. As I told you, whenever one is going to talk about control flow instructions, the very first instruction that comes into the mind of any microprocessor programmer, that will be jump instruction. And here we comes to a very important fact which we have learned while we were discussing memories, while we were discussing segmentation, while we were discussing execution of program itself, and we also discussed pipeline, if you remember. So that in that concept we discussed IP and CSR concept, the code segment register and the IP segment register, how they are going to relate it here in this discussion. You know that as I told you in previous slide, whenever microprocessor is executing instruction number 1, so basically number 2 is in execution, and whenever number 2 is under execution, so number 3 is under fetch. Okay, I think if I mistakenly said wrong, so I will just repeat myself. For example, if number 1 is under execution, so number 2 would be under fetch, right? When number 2 is under execution, so number 3 would be under fetch. So that means next instruction is going to be fetched. But how the microprocessor is tracking that next instruction, or next or tracking that location which is storing this next instruction, and those this tracking job is done by these two registers, CSR and IP. I hope you remember it. CSR holds segment base address, and IP holds the offset address, or the offset part of the address. You know that that is the logical address. Both are 16-bit register. So that means if one is interested to interrupt that regular routine or regular sequential flow of execution of instruction, then he has to or she has to interrupt, or he has to or she has to play with these two registers. What you have to do, you have to just change these instruction contents. Okay, so control in flow instruction, for example jump instruction, must change the content of what? CS or IP content. So for example, we know that the content of CS and IP was leading towards this instruction, CS colon IP, but what we did, we changed the value of IP. So somehow CS colon IP will point to different let me write again. For example, number 1, then number 2, and we were discussing number 3. So you know that this address was being pointed by these values of CS and IP, right? So somehow we change the value of IP. So what will happen once we are going to calculate the physical addresses? So last time it was pointing towards 3, but it will point towards certain other instruction or certain other location. That will be the instruction we are going to jump. Let's say we are going to jump on 40 instructions. So that change in the IP or either change in the CS may lead towards different instruction to be fetched, and that means we are changing the flow of instruction or changing the flow of execution. That so this is the conclusion of this point, that whenever one is interested to flow to change the flow of instruction, then one has to change the content of CS or IP. Thus different addresses are used to fetch in to other instruction. As I explained you, this point is already clear. And then to cause a different execution instead of normal sequential flow, as I told you, instead of third instruction we were leading towards number 4 instruction. So that is basically different execution sequence, and what we are avoiding normal sequential flow. So that is the magic of changing the content of CS and IP, and that is being done by this jump instruction. We're gonna see how this instruction works. Okay, once we are going to talk about jump instruction or conditional flow instruction, then we need to deal with two different kinds of jump instruction. One is called unconditional jump, and other is called conditional jump. So in this slide we are going to discuss about unconditional jump. Unconditional jump, that means whenever that jump instruction is going to appear in that program, you have to jump wherever he is sending you. You have to go to that instruction and skip the next instruction, whatever the code is written. You have to skip the next instruction and you have to jump wherever he is sending you. So that is called unconditional, because there is no condition or there is no excuses you can make to this instruction, and it will definitely interrupt the sequential flow of your program. Okay, to understand this logic, we have constructed this diagram. Let's see. Let's say this is our main program memory, and we are working on this part of memory. Let's say, let me draw it. This is the part of the program memory, and we are going in this direction. Look, right, there will be number of instruction 1 2 3 4 5. Suddenly we encounter this instruction JMP jump AA, right? AA is argument, and we're gonna learn about it. But what we are interested here, it is jump instruction, and that is what, that is unconditional jump, right? That we have already seen that that is a unconditional jump, and there will be no excuse. So wherever he is sending, we have to go. So he is sending us on AA. So what we have to look for, we have to look for in this program memory where AA is mentioned. Look, this is the part where AA is mentioned. So that means you're gonna jump from this instruction. After this instruction, whatever the part, this is the part which is going to be skipped, right? I have also written here, this is the part which is going to be skipped, and the jump instruction will be jumping towards this label, whatever this label is. And we're gonna see how these labels works in assembly language programming, but we at this stage we are just learning wherever he will find this AA, he will jump to this label, and then this part of code is going to be executed. So that is the flow of jump instruction or unconditional jump instruction, because we saw a jump instruction in program, and after that whatever the part was skipped, and that part which starts with AA or the label or the operand of the jump instruction is going to execute it to be next, right? I hope this flow chart is clear to you. Okay, in this slide we are going to talk about the mnemonic and the format of the instruction, as we have been doing for all kinds of instructions so far. So the mnemonic of this instruction is what? Jump. I hope this point is clear to everyone. JMP jump, and its meaning is unconditional jump. So there will be no condition to check at all, and there will be no excuses to make, and we have to jump wherever he is standing. What is the format, as we saw in that flow chart as well? So jump operand, whatever the operand is mentioned, we have to go to that operand. That operand could be a simple label, a short label, long label, and could be a register value. So how those things will be discussed, we gonna see in emulator example as well. But we one need to consider that whenever JMP jump operand is considered, then we have to look, we have to jump anyway. So this is what written in this operation part. Jump is initiated to the address specified by the operand. So whatever the address is specified by the operand, you have to jump to that location anyway. So it will disturb the sequential flow of instruction. One thing which is noticeable, this jump instruction is not going to affect any of the register. That is why flags effective indicates none of the flag will be affected. So this means whatever the arithmetic and logical operations you were performing and their effects were saved in the status register, so those will remain saved in status register. Those will never be altered by the use of jump instruction. So you can simply use jump instruction without affecting your flags. That is the also important noticeable point. Okay, in this slide we are going to speak about jump instruction, and we're gonna learn very simple context of jump instruction. So let's start our example. Let's say our line number 1 is what, move AX comma, let's say 1 2 3 4 hex. Move PX has a certain value, for example okay, this time we take a different example. Okay, 04 hex, and this is saved in a accumulator, and we gonna say that CL is basically 02 hex, right? And then we multiply CL. You know, this is just multiplication between CL and AL, and the result will store in AX, right? And then we write jump to, let's say, AA, which was a label, and then we wrote move whatever the information is stored in AX, which is the result of in BX, right? And then we move value BX into CX, and then I'm just doing a random stuff here, okay? And let's say we use AA is equal to, colon. This is the syntax of this instruction, increment let's say whatever the result was AX, right? And okay, and then what happened, then we saw whatever the result was moved in DX. Okay, so I'm just going to execute this instruction to let you know how this program going to work. Okay, and I can squeeze it up till here. Okay, and then let's press emulate button, so everything is okay, everything seems in order, right? And what thing is we are missing? Probably we are missing this flag, right? These flags are also clearly now shown. So let's execute this program. What is going to happen? So very first line number 1, it says AL will be used as a destination, and 04 will be loaded. So we press single step, we saw 04 is loaded. If there is any effect, we're gonna see, but since it is just a data transfer function, so it won't affect any flag. And AL has 04 now. Next thing, this is line number 2, it moves CL comma 02, so we're gonna write, so CL is actually 02. Furthermore, one can see that there is no effect on flags register. Okay, the line number 3 is mul CL, which means whatever the value of CL is going to multiply it with what? Accumulator or AL, and the result will be stored in AX. So let's see, 04 will multiply it with 02, in both are in hex, so 08 will be result, and that will be shown in AX. So let's see, yes, 08 is shown. I hope this point is clear to everyone. So far we have executed only 3 different lines, and now we are going to execute this line number 4. So let's see what is going to happen. Look, this line is highlighted once I'm going to press it. Okay, what is expected to be done? If it was a normal instruction, then it will be jumping on line number 5. For example, let me step back. So we again are on this point, mul CL, this is highlighted. So as I going to look, this is highlighted, line number 3 is highlighted. As I'm going to single step, it is jumping on line number 4, which is the normal routine, because you have just executed what? Line number 3. So line number 4 would be the next instruction which is going to be executed, but it is a jump instruction. At line number 4, what we have written is a jump instruction, so it will disturb the original flow, and it will cause it to move to that operand. And what that operand is? That operand is AA, and you see that operand is mentioned here. Okay, you need to just remember that AA or any label you can use here. Of course, you cannot use the default or predefined keyword which are dedicated for certain instructions. So whatever except those keywords, you can use any of the alphabetical label, and after that label you have to press this colon, right? This is the indicating that this jump command is going to jumping towards this label. So what we see this label instruction is instruction number 7. So that means after the execution of instruction number 4, where it is jump AA, line number 5 and line number 6, it is going to be skipped. So these two instructions which is going to be skipped, and we will be jumping on line number 7. So let's see if it is going to happen or not. So single step, and I hope you can see that program is being jumped. So let's see. The next thing which is going to happen is, okay, here we are. Okay, I think one mistake was there because I changed this label, so probably that is affecting. Let me load it again. 04, 02, 08. Yes, that was the mistake because I put here gap, which is not supposed to be there. So I have to emulate this program completely. Let me emulate it again so that it becomes easily understood. So single step 04 is loaded, single step 02 is loaded, single step multiplication is done. So after this jump instruction, this command should be highlighted. Let's see if it is going to be highlighted or not. So single step, and one can see that the next instruction which will be executing is this instruction INC Okay, so whatever this label, it will not affect the function of this instruction. Whatever the function of this instruction is going to happen, so you know that it says there will be increment in AX, right? So increment in AX means AX value is currently what, 08. So it will be incremented and it will be becoming 09. Let's see. Yes, it is 09. Okay, here we have to just see that line number 5 and line number 6, both of these lines are skipped. So whatever the function was written there, they never executed. That means you will be having no effect of no usage of these instructions. At this stage, probably you see why these two lines were written, even if their function was not supposed to be taken into account. So at this stage, maybe this seems a bit rough, but you know that in certain application you are used to skip certain part of program, and certain part of program is selected upon the different conditions or different unconditional jumps. So this is one of those example. Let's proceed to the next line, which is what it says: whatever the value of dx should be, whatever the value of x should be moved in dx, and one can see that 09 is loaded in dx. So I hope you have seen the program example of jump instruction, unconditional jump. Hopefully this is clear to everyone. Okay, that's it from this lecture. So today we learned about unconditional jump and how one can use unconditional jump in any program of 8086 or 8088 microprocessor. And I hope these points are clear in your mind. If you have any confusion, please note them down, and we're gonna discuss those confusion in online session. Thank you so much for listening.